Big Bud 747 is the best tractor for pulling big loads or planets. This bad farm boy is proof that America is king of big machines. With a 1,100 GP output by the end of its days, it was capable of an acre-a-minute plowing rate. Currently, though retired from regular duties, the Big Bud flexes its muscles once in a while with its 80-foot-wide Frigstad chisel plow at Williams Brothers Farm. Although Big Bud isn't the most efficient tractor in the world, and there are now many alternatives that make the same or more power per weight, the Big Bud is 50 tons when rolling. Robotic operation in the desert is a remarkable example of how technology addresses the challenges of reforestation in arid regions. After finding a suitable spot, the robot will use its robotic arm to dig a hole in the ground. The task of placing a sapling in the hole will be taken up by another robot then. With precision and efficiency, the robot continues this process, planting trees across the desert. The entire operation is monitored and controlled by a centralized system that monitors the progress of each robot, ensuring optimal planting patterns and efficient reforestation. The LSB 1290 ID lawnmower is an advanced and highly efficient agricultural machine. The grass baler starts by using a collection mechanism to collect the cut grass from the ground. The collection boxes, strategically placed on a rotating shaft, lift and feed the grass into the baler's chamber. When the cavity is filled with grass, the piston moves back and forth, compacting the material to ensure a strong bale structure. The baler uses a wire or net winding system to securely tie the bales as they exit the chamber. After the bale reaches the desired size, it is ready to discharge. The baler automatically pushes the finished bales out of the chamber and onto the conveyor system or directly on the ground, where it can be collected for further processing. The orange harvester is designed to be fun and efficient with 6 robotic arms with each farmer on one arm. To ensure the highest quality harvest, each robotic arm has a farmer who personally picks the fruit. As the orange harvester moves through the orchard, the robotic arms precisely reach the ripe oranges. As the robotic arms harvest oranges, a conveyor system collects the fruit and transports it to a centralized location. This automated dispensing process maintains a constant flow of oranges for further processing or packaging. The Universal Onion Digger is a tow-behind machine that is attached to a tractor for easy maneuverability in the field. It's equipped with a series of adjustable blades that dig into the soil to lift and separate the onion bulbs from the ground. The onions are then moved along a conveyor belt where any remaining soil or debris is removed before the onions are placed into windrows for further processing. This image, taken in September 2019, showcases a Ford 6000 Commander tractor, which was introduced in the 1960s. The tractor is equipped with a stone picker mechanism used for sieving soil and removing rocks. The Ford 6000 Commander series was manufactured by the Ford Motor Company to meet the transportation and heavy-duty requirements of the agricultural industry during the 1960s. With the help of this tractor and the rock filter mechanism, removing a layer of rock from this 112-hectare field is not an easy task. This farmer's innovative spirit led him to create his own machine for soil heat treatment. The heat destroys weed seeds and pathogens while also improving soil structure and nutrient availability for crops. The harvesting and clearing equipment manufactured by Hilaris is a versatile tool used in animal feed processing. This tool is attached to a small excavator, and the combination is utilized to scoop and pile up feed for easy access during cattle feeding. The Hilaris Uyan Lufmeyer Union Royer 225 front combi is an onion harvesting and cutting machine specifically designed for onion harvest. Hilaris specializes in manufacturing this tool for efficient onion harvesting. The Uyan Lufmeyer is the front part of the device that utilizes the blade, and the Union Royer is the part of the machine responsible for harvesting onions. It can grasp and pick up onions from the ground, bringing them to the surface for harvesting. This greatly increases the speed and efficiency of onion harvesting. Of celery harvest. What stands out the most is an extensive mobile harvesting system resembling a moving assembly line. Celery plants are trimmed, removing their leaves, and then placed on a conveyor belt. The following steps involve processing and packaging, with each person assigned a specific task. The harvested celery quickly transforms into food, ready to be sent to the market for consumption. Join us on a journey to a large red cabbage farm in the Netherlands. In September every year, red cabbage harvesting begins. The farmer starts using modern machinery to harvest his product. One of the most impressive machines he uses is the ASA Lift Reaper. This machine is designed as a mobile cabbage factory with the ability to harvest, pick, and store this dedicated crop in the shortest time, ensuring fresh vegetables all year round. The harvester is operated by two people who direct the harvesting and picking of red cabbage. The crops are cut with high-precision blades and delivered to the storage box on the machine to keep them fresh. With the ability to harvest quickly and save labor, this machine helps increase productivity and production efficiency. This amazing machine has proven to be a useful tool in the farming industry here. Water cooling, forced air cooling, or vacuum cooling. Agricultural grading and quality control technology plays an important role in ensuring that only the highest quality products reach the market. At processing facilities, agricultural products are thoroughly inspected and classified. Trained personnel or automated systems check factors such as the product's size, shape, color, maturity, and overall appearance. Agricultural products are then graded and graded based on specific criteria. Classification systems can vary depending on the type of product, but they usually involve the designation of a grade or classification that indicates the quality and market value of the item. Harvesting floating rice, also known as floating rice farming, is a unique and innovative method practiced in certain areas with flooded fields. The specialized floating rice harvester is a unique machine designed to operate on water. It is equipped with a combined mechanism for cutting and transporting to efficiently harvest rice without damaging the crop. As the harvester moves through the field, it gently pulls the floating rice plants into the machine. The cutting mechanism trims the rice plants, and the seeds are collected into the reaper's hopper. The Oxbow 2480 is an advanced fresh corn harvester, using a sophisticated picking mechanism equipped with reels and collection lines. The snap rolls gently separate the cobs from the stem, and the collection lines transport the harvested corn to the cleaning system. Once the corn is picked, it goes through a cleaning system to remove the husks, silks, and other debris from the corn kernels. The separated corn is then transferred to a hopper or wagon for further processing. To harvest, store, and transport straw, with today's technology, we often use these common methods. Circular composting is a common method for harvesting grass on farms. In this technique, a specialized circular baler is used to collect the cut grass and compact it into large cylindrical bales. Square baling is another method used to harvest grass on farms. In this process, a square baler collects the cut grass and compresses them into compact rectangular bales. Once baled, the harvested grass can be shipped directly to its intended destination, such as a feed mill, livestock farm, or commercial buyer. When the cotton reaches maturity, it is time to harvest. Large-scale cotton farms often use the growing cattle grass by hydroponics in containers is a modern, innovative method of providing nutritious and efficient feed for livestock. Hydroponic systems are designed to grow grass without soil, using a nutrient-rich water solution to nourish the plants. Grass seeds such as barley, wheat, or oats are first germinated in a separate area before being transferred to hydroponic trays. Since the grass is grown in an indoor container, LED grow lights are used to provide the light spectrum needed for photosynthesis. Once the grass has reached the desired maturity, it is ready to be harvested. The grass can be cut manually or using automatic harvesting tools, and the harvested grass is fed directly to the cows. The remote-controlled robotic digital farm operation represents the integration of cutting-edge technology into modern agriculture. All the farmer needs to do is work on the computer. Operating a digital farm begins with a centralized control center equipped with sophisticated software and sensors. This center serves as the brainstorm of the entire operation, allowing farmers to monitor and control the robot remotely. The farm uses a fleet of automated robots, each equipped with sensors, cameras, and actuators. These robots are designed to perform a variety of tasks, such as planting, sowing, weeding, harvesting, and even monitoring crop health. Red beet agrotech activity involves growing and managing red beets using advanced techniques to ensure optimal growth, quality, and yield. Here is an overview of the main steps involved in this process. Before sowing, the soil is thoroughly worked to ensure good drainage, fertile, free from weeds and pests. Then seeds are sown directly into the soil. Irrigation systems are used to provide enough water for crops. Radishes are usually ready for harvest 20 to 30 days after sowing, depending on variety and growing conditions. Farmers use mass harvesters, carefully lifting the radishes out of the soil. The harvested beets are then packaged and prepared for distribution to markets, grocery stores, or restaurants. Korean ginseng cultivation techniques involve a complex and carefully planned process to grow high-quality ginseng roots. The process begins with the large-scale planting of ginseng seeds or rootlets in carefully prepared soil. Ginseng requires consistent moisture throughout its growing cycle. A precision drip irrigation system is used to deliver water directly to the root zone, minimizing water waste and ensuring the ginseng plant receives enough water. Korean ginseng is usually harvested after a growth period of about 5 years. Once the ginseng roots have matured, they are carefully dug out of the soil to preserve their quality. After harvesting, ginseng roots undergo deep processing to prepare them for the market. The technology involved in planting 10,000 acres of vineyards is a complex and precise process that ensures optimal viticulture. The vines are planted at specific distances and depths, ensuring proper spacing and anchoring. The weeder is designed with a precise weeding mechanism to target and remove weeds around the vines. Regular pruning of the vines is essential to maintain their shape, balance vegetative growth, and optimize fruit production. After the grapes mature, the fruit is harvested by the New Holland grape harvester with a harvesting mechanism designed to be gentle on the bunches of grapes. It uses rubber bands or shakers to carefully separate the grapes from the vine, avoiding damage to the fruit. Now, machines constitute the primary labor force on large-scale farms. Nio Technologies is currently working on a weeding robot that walks between vegetable beds for mechanical weeding for large-scale vegetable farms. This new robot is especially useful in weeding and farming. It is designed to weed industrial crops automatically and without human supervision, thanks to its guiding mechanism as well as its weeding and hoe tools. Bourgault currently manufactures the world's largest productive sewing rod, model 3420, with a sewing width of 30 m, the L9950 towed air seeder with over 33,000 L. Bourgault 9950 is equipped with precision seeding technology, which ensures precise and uniform seeding throughout the field. This results in optimal seed-to-soil contact, improved germination rates, and overall plant establishment. Furthermore, the machine's cross-sectional control system allows individual rows to be turned off, preventing overlap and optimizing seed utilization, reducing waste and costs. This feature ensures that seeds are sown only where needed, avoiding unnecessary seed dispersal in already sown areas. Thank you for joining us on this fascinating journey into the world of future agricultural technology. The innovations and advancements we have discovered today hold great promise for a more sustainable and productive future of agriculture. Finally, goodbye and see you again. Holes for crops. It utilizes drilling technology to perform farming tasks automatically. The robot can be programmed to pinpoint the exact locations to drill holes for planting trees. And then it uses its robotic arm to carry out the drilling process. This automated method saves time and effort compared to manual planting methods. This mini harvester creates many haystacks. This is a feed sweeper device, specifically the Halara/Viral V'ger/Feed Sweeper Wheel type Octo 1500, which is used in the livestock and agriculture industry to sweep and collect various feed ingredients from a large area. It is designed to collect feed ingredients such as grass, straw, feed mix, or breweries' used grain from the ground. The purpose of using this mechanism is to efficiently gather feed ingredients from large areas. Its rotating wheel system allows it to move flexibly on the ground, ensuring efficient storage of the collected feedstock. The multi-row eco-weeder operates by using a series of rotating brushes to remove weeds from the soil surface. The machine can be adjusted to accommodate different crop types and row spacing, making it a versatile tool for weed control in a variety of agricultural settings. It's also designed to work in a variety of soil conditions and can be used in both dry and wet conditions. This device is mounted on the tractor body, and its purpose is to rotate and mix grass, straw, or fodder. The mixing of straw and hay to create animal feed is crucial to preserve food reserves, prevent spoilage, mold, and avoid health problems for livestock.